transfer function. What is the open loop transfer function he is giving? K by S into S plus 2 into S plus 4. And he is giving open loop transfer function and he is asking about this particular point lies on the root locus branches or not. So now he is asking the second point at S equal to minus 3. Therefore, the angle of open loop transfer function at S equal to minus 3 is nothing but minus 3 plus 2 minus 1 minus 3 plus 4 plus 1. Therefore, which is nothing but K plus J0 and this is 3 plus J0. Now, I want to find angle of G of S. I want to find angle of G of S at S equal to minus 3. Angle of G of S at S equal to minus 3. Now this is tan inverse imaginary part by real part. 0 by K. Tan inverse imaginary part by real part. And this is tan inverse imaginary part by real part. Therefore, this is 0 degrees by 0 degrees, which is equal to 0 degrees or plus 360 degrees or minus 360 degrees. But if you observe, the angle of open loop transformation at this particular point is not a odd multiples of plus or minus 180 degrees. It not satisfy the angle condition. Therefore, S equal to minus 3, which does not lies on root locus branches, which does not lies on root locus branches, because the root locus branch is a branch which is a moment of the closed loop pole. This itself is not a closed loop pole, therefore it is not lies on that particular closed loop pole moment. Okay, but previously S equal to minus 1, which is a lies on root locus branch because it satisfies the angle condition. Now in that way you can easily identify the following point lies on the root locus branches or not. Okay, now this is the important one, how the angle condition and all these conditions are useful to you. Okay, now this is our first example. So then I think you understand where we use the angle condition and magnitude condition. Okay, we just take this one also. Right. Now we'll take one more question. This is the transfer function which is given, G of S, which is equal to K by S into S plus 6, and identify the point S equal to minus 3 plus J3, which lies on the root locus branches or not. See, I am using the word point because the real part, imaginary part. Here real part is there, imaginary part is 0. Okay. Now what is the question? He is giving again the same open loop transfer function, and this particular point lies on the root locus branches or not, and also find the system gain at this particular point. This is the question. Okay. Now this particular point lies on the root locus branches or not is first question, and second bit is at that particular point what is the system parameter called as system gain, how much it is. He is asking that particular 2 bits in the same question. So first you want to identify that particular point lies on the root locus branches or not. How we can identify? Now at this particular point you measure the angle. Now G of S at S equal to minus 3 plus J3, which is nothing but K divided by minus 3 plus J3 and minus 3 plus J3 minus 3 plus J3 plus 6. Now G of S at S equal to minus 3 plus J3, which is equal to K plus J0 divided by minus 3 plus J3 and 3 plus J3. Minus 3 plus J3 and 3 plus J3. So the angle of open loop transfer function at S equal to minus 3 plus J3 is numerator. Positive constant angle is always 0 degrees. But this is the real part which is negative. Therefore, 180 degrees plus tan inverse imaginary part by real part multiplied with tan inverse imaginary part by real part. Therefore, the angle of open loop transfer function at S equal to minus 3 plus J3, which is equal to 0 degrees by, now tan inverse 1, this is tan inverse 1 is 45 degrees, 180 degrees minus 45 degrees, and this is tan inverse 1, which is nothing but 45 degrees. Therefore, this is 0 degrees by 135 degrees into 45 degrees, theta 1 into theta 2, 135 plus 45 degrees. Therefore, 0 degrees by 180 degrees, which is nothing but minus 180 degrees. Minus 180 degrees. Now the question is, now this is minus 180 degrees, the angle of open loop transfer function at S equal to minus 3 plus J3, which is equal to minus 180 degrees. Minus 180 degrees. Now the angle of G of S at S equal to minus 3 plus J3, now which is minus 180 degrees. Now see here, this is minus 180 degrees. Now angle of open loop transfer function at this particular point is an odd multiples of plus or minus 180 degrees. Therefore, this point is lies on root locus branches. This point is lies on root locus branches. Am I not? So it satisfies the angle condition. Therefore, it lies on root locus branches. Now he is asking the B bit. Now first he is asking this particular point lies on the root locus branches or not. Yes, this particular point lies on the root locus branches. Note down first. Now this particular point lies on the root locus branches or not? Yes, this particular point lies on the root locus branches because it satisfies the angle condition. Now they satisfy the angle condition means it is a link between open loop and closed loop. Now the second bit, at this particular point he is asking the system gain K. At this particular point he is asking the system gain K, and you know one more condition, when angle condition is satisfied and it will automatically satisfy the magnitude condition. Am I not? The magnitude condition is applicable only when the angle condition is satisfied. So can I use the magnitude condition and find the system gain at this particular point? Yes. If you use the magnitude condition at that particular point at S equal to minus 3 plus J3. So the magnitude condition, which is nothing but magnitude of K plus J0 minus 3 plus J3 and 3 plus J3. Now this is the magnitude which is equal to 1. Am I not? This is the magnitude condition. Don't apply magnitude condition everywhere. Apply the magnitude condition only when the angle condition is satisfied. In this question, the magnitude condition is satisfied, so you can use the angle condition is satisfied, therefore you can use the magnitude condition. So square root of real part square plus imaginary part square divided by square root of minus 3 square plus 3 square, square root of 3 square plus 3 square, which is equal to 1. Therefore, K divided by root 18 into root 18, which is equal to 1. Therefore, k equal to 18. Now, this is the system gain. This is the system gain at this particular point. Okay, by using magnitude condition, you can easily find this. Okay, now in that way, you can use the angle condition and magnitude condition. Angle condition is satisfied is nothing but it is a closed loop poles. It is the closed loop behavior. It is the characteristic equation. If the angle condition is satisfied, you can use the magnitude condition. Otherwise, the magnitude condition is not possible when the angle condition is not satisfied. Okay, note down this. Sir, again calculating the angle condition, magnitude condition, it is a lengthy analysis and it will take more time for me. No, by looking that particular trans function, can I say this is lies on the root locus branches or not? Yes, there is a shortcut method for that. Now I am giving that shortcut method, you just try to understand that. Now this is one open loop trans function, g of s, which is equal to k into s plus 1 by s plus 2, and this is another trans function g of s, which is equal to k into s minus 2 by s into s plus 1 into s plus 3. Okay, now see here, these are the few transfer functions which is given to you, open loop trans functions, and identify the root locus branches. What is the meaning of root locus branches? Root locus branches is nothing but movement of the closed loop poles. Okay, now first you locate the poles and zeros on S plane. Locate the poles and zeros on S plane. 1, 0 is at minus 1 and 1 pole is at minus 2. Is it right? And here is also you just locate the poles and zeros on S plane. Now 1 pole is at origin and 1 0 is at plus 2 and 1 pole is at minus 1 and 1 pole is at minus 3. Okay. Now the question is, identify a point is on the real axis. Put a point on the real axis, anywhere on the real axis, positive or negative, entire real axis. If I put a point here, this is a point. Okay. See the number of poles and zeros to the right hand side of this point. So how many poles and zeros to the right hand side of this point? Now this is the point right hand side, only 1 0. Count all the poles and zeros to the right hand side of this particular point. The right hand side of this particular point, only 1 0 is an odd number or an even number? Is an odd number. Now if it is an odd number, then there exists a root locus branch. Now this section is nothing but the root locus branch. The root locus branch is nothing but a movement of the closed loop poles. Okay, this branch is nothing but a root locus branch, which is a movement of the closed loop pole. This is the closed loop pole movement. This is the closed loop pole movement. Now this is the point. Now the point right hand side, this is the point. The point right hand side is only one odd number. Therefore, there is a root locus branch. This is the point right hand side 1 and 2 even number, no root locus branch. This is the root locus branch. Now if I put a point here, point right hand side, 1, 2, 3, count total 3, odd number, there is a root locus branch. There is a root locus branch. Now this is the point. Now this point right hand side, 1, 2, 3, 4, even number, no root locus branch. Now this is the point. Now the point right hand side, 1, 2, even number, no root locus branch. Understand or not? Take a point, see the number of poles and zeros to the right hand side of a point is an odd number, then there exists a root locus branch. This is the root locus branch, is a moment of the closed loop pole, is a moment of the closed loop pole. And students are asking, sir, what is the root locus branch? Then the root locus branch is a moment of the closed loop pole. Why this is only the root locus branch? Why this is only root locus branch? If you have any doubt, take a point here and find the angle. That angle is an odd multiples of plus or minus 180 degrees. That's why I will take it as an odd number as a condition. Okay. What is the general procedure? Odd angle of angle at that particular point is an odd multiples of plus or minus 180 degrees. Now that's why I just take an odd multiples of poles and zeros to the right hand side of that particular point. Sir, how I can use, how it is useful to you? It is very useful. That's why you solve your first problem once again. Now what is your first problem? Your first problem is this, g of s, which is equal to, now in a shortcut method we will solve k by s into s plus 2 into s plus 4. Now first locate the poles and zeros and explain. One pole is at origin and one pole is at -2 and one pole is at -4. Now locate the poles and zeros on S plane. Now this is the root locus branch. Point right hand side 1. Point right hand side 1 and 2 even, no root locus branch. Now this is the root locus branch. Point right hand side 1, 2, 3, odd number is a root locus branch. Now see here, this is the root locus branch. This is not the root locus branch, is a even number. Now what is the question he is asking? He is asking 2 points which lies on the root locus branches are not. First point, s equal to -1. S equal to -1, which lies on the root locus branches or not. Where is the root locus branch? The moment of a closed path is existing between 0 to -2. So -1 is in between this particular path or not. Therefore, s equal to -1 is lies on the root locus branch. Now the question, another question. Now s equal to -3, which is lies on the root locus branches or not. But -2 to -4, now in between this -3 is existing, but -2 to -4, is there any root locus branch? No. Between -2 to -4, no root locus branch. Therefore, s equal to -3 is not lies on the root locus branch. No angle condition, no magnitude condition, nothing. Now with this shortcut method, now you can easily identify the given points which lies on the root locus branches or not. Okay. But one condition is that now this shortcut method is valid, and this method you can follow, you can apply only when the poles and zeros are having only real part. Okay. Only real part. Real pole, real zero, real zero, real pole, real pole, real poles, real zeros. If the poles and zeros are lies only on the real axis, then this shortcut method straight over you can use it. No sir, if the poles are complex conjugator, then what should I do, sir? That's why I give the second problem now while doing the concept of the root locus diagram. Now when it is a complex conjugate poles and identify it lies on the root locus branches or not, and you have to go for the angle condition and verify the angle condition. If the angle condition is satisfied and that particular point lies on the root locus branch. That is the reason why now I am not doing this first. I am doing first a general procedure. Then if you understand the general procedure of with the 2 examples, then you can easily understand this shortcut method. Okay. This is valid only poles and zeros are having a real parts and real axis poles. Okay. Note down this. Now use this shortcut method from the next problems onwards for identifying the root locus branches. The root locus branch is nothing but movement of the closed loop poles. Where the closed loop poles are moving, the movement of the closed loop pole is nothing but the root locus diagram. Let us take one small example here. Here is the example. This is the root locus branch. Now students are asking question. So root locus branch is nothing but movement of closed loop poles. What is the root locus branch? Root locus branch is nothing but closed loop poles movement. Sir, how that movement is taking place? That movement is starts from Hyderabad to Bangalore or Bangalore to Hyderabad. Now how, sir? Where it will start? What is the starting point? What is the ending point? For that particular question only, we'll start our first point in the root locus diagram. The first rule in the root locus diagram, the root locus diagram starts with open loop pole, starts with k equals 0, ends with open loop 0, ends with k equal to infinity. So no confusion. The root locus diagram starts with k equal to 0. The root locus diagram starts with open loop pole. As k is changing, when system gain k is changing, closed loop pole is a function of system gain k. So when k changes, closed loop pole is also changes. As k is changing, closed loop pole is moving, because this is the movement of the closed loop pole, because this is the root locus branch. As k is changing, and the root locus diagram ends with k equal to infinity. The root locus diagram ends with k equal to infinity. The root locus diagram ends with open loop 0. Now see here, the root locus diagram starts with open loop pole, end with open loop 0. The root locus diagram starts with k equal 0, ends with k equal to infinity. So closed loop pole is equal to open loop 0. Closed loop pole is equal to open loop pole when k equals 0, k equal to infinity. Now this is called as complete root locus branch. This is called as complete root locus branch. What is a complete root locus branch? The complete root locus branch is a branch where it starts at poles and ends at zeros. Our entire root locus diagram is to be drawn where it will start at open loop pole and ends at open loop 0. Okay, the complete root locus branch is a branch where it starts at open loop poles and ends at open loop 0. You already have the open loop pole equal to closed loop pole when k equals 0, open loop 0 equal to closed loop pole when k equal to infinity. So this is a closed loop pole movement. Now in the same way, so I have another situation here. This is another situation. This situation is complete because starting, ending. Now here it will start, here it will end. It is over. The life is closed. Okay. But now what about here? The root locus diagram starts at k equals 0, starts with open loop pole. The root locus diagram starts with k equals 0, starts with open loop pole. As k changes, closed loop pole is moving. As k changes, closed loop pole is moving. As k changes, closed loop pole is moving. Then you observe here, at one particular point, these two closed loop poles are meeting. At one particular point, these two closed loop poles are meeting. For what purpose this closed loop poles movement is taking place? For getting one complete root locus branch. What is a complete root locus branch? Starts at poles, ends at 0. But 0 is available here? No, this is pole. Therefore, here is also starting. Here is also starting. Now, at this particular point, then these two poles are meeting and put at this particular point, these two closed loop poles are meets and meeting point will be sharing those problems. Okay. Now, what this pole is saying? This pole is saying that I am searching for this 0. And what about this pole is saying? And this pole is also saying that I am searching for a 0. Oh, we both are searching for the zeros, and at this particular discussion, then between these two particular poles, and they are saying that you don't go this side because you will never get a 0. And this pole is also saying you don't go this side because I will check from here to here, then there is no 0 here. So now where the 0? So one point is conclusion that now the 0 is not on this particular axis. Is it clear or not? But see the situation here. Now the pole is moving, 0 is available, directly go and terminate it there. Now pole movement is started, but it is not completed because 0 is not available for both the poles. So at this particular discussion, they are saying that they decided that, oh, we are not getting any 0 on this particular axis. So we have to leave this particular axis now to search for a 0. Understand or not? Now we don't get any 0 on this particular axis because you are searching from this end to this end and I am searching for this end to this particular point. So we both are now ready to leave the real axis at this particular point for finding a 0 to make a complete root locus branch. That particular point is called as this particular point, this particular discussion point, this particular discussion room, this particular meeting point is called as break point. Is called as break point. Understand or not? This particular point is called as break point. Now actually the break point is of 2 points. One is break away point, another one is break in point. Break away point and break in point. But this breakaway point or break in point is called as simply break point. Sir, you say this break point comes under category of breakaway point or comes under category of break in point. That we will discuss. Now first you just take these examples. Okay. Now this is the complete one, but it is not a complete. To make a complete, so it will leave the real axis. Now that a particular point, that particular point is called as break point. Okay, note on this. Okay. So only one small logic, if you observe or not, in an entire root locus diagram, you are searching, you are trying to draw the complete. If any incomplete, then you make it complete. Incomplete means pole starting, ending is 0. But that is not available, then you will make it a complete root locus diagrams. Okay. Now the situation here, sir, this break point is nothing but a breakaway point or break in point. Is easily away or in. This is away point or in point. Now at this particular point, what they are decided? They are deciding that this is the point where the root locus branches. This is one root locus branch. This is another root locus branch. These two root locus branches leaves the real axis. Breakaway point is a point where the root locus branches leaves the real axis. Breakaway point is a point. Breakaway point. Note down the definition. What is breakaway point? Breakaway point is a point where the root locus branches leaves the real axis. Now a breakaway point is a point the root locus branches leaves the real axis. Now at a particular point, that particular point is called as breakaway point. And students are raising a question that, sir, one pole is at -1, another pole is at -3. Breakaway point is exactly middle or close to -1 or close to -3? No, that we are calculating, but one thing is confirmed, the breakaway point is existing between -1 to -3. I cannot say that is exactly middle. It may be close to -1 or it may close to -3, but it is there in between -1 and -3. Okay, that is one important point, students. This is one shortcut method I am finding. The possibilities of existing breakaway point. This is one possibility, am I not? This is one possibility. This is one possibility of existing breakaway point. So what is the possibility? There exist two adjacently placed poles. There exist two adjacently placed poles. Between them there is a root locus branch. There exist two adjacently placed poles. Between them there is a root locus branch. Definitely there is a chance of existing one breakaway point. There is a chance of existence of one breakaway point when the situation is demanding that there are two adjacently placed poles. Between them there is a root locus branch. Then there exists one breakaway point minimum. Understand not? This is one possibility of existing the breakaway point. Now the second question is, now another possibility. We'll see all the possibilities. Okay. Now see here. Now students are thinking that there is two adjacently placed poles. There is two adjacently placed poles. Therefore, there exists one breakaway point. Is a wrong answer. Okay. No breakaway point here. There is no breakaway point here. Don't confuse. There is no breakaway point. Why? Why there is no breakaway point? This is the root locus branch. This is the root locus branch. But this is not the root locus branch. This is not the root locus branch. Point right hand side 1, 2. Even no root locus branch. Now point right hand side 1, 2, 3. This is the root locus branch. This is the closed loop pole movement. This part is the closed loop pole movement. There is no closed loop pole movement here. How you can say that there is leaving, there is entering? Understand or not? There is no break point. Don't blindly remember that two poles break away, two zeros break in. Wrong statement. There exist two adjacently placed poles. Between them there is a root locus branch. Then only there is a chance of existing one breakaway point. Now here there is no breakaway point. Remember this situation. Two poles breakaway point, two zeros break-in point. Wrong statement. Now there exists a breakaway point. Now first there should be a root locus branch between that particular section. Okay. Now this is one possibility. This is another possibility of existing breakaway point. There is no breakaway point here in this situation. No breakaway point, nothing. Clear? This is another situation. There is no breakaway point. Now there is another situation I am writing. Now this is the second situation. Now first identify the root locus branches. There is a root locus branch here. Now there is no root locus branch. Now this entire real axis is a root locus branch. This entire real axis is a root locus branch. Now one question. Leftmost side there is a pole. Leftmost side there is a pole. After that pole, entire real axis is a root locus branch. Leftmost side there is a pole. After that pole, entire real axis is a root locus branch. Leftmost side there is a pole. After that pole, entire real axis is a root locus branch. Am I not? Leftmost side there is a pole. After that pole, entire real axis is a root locus branch. Then there is a chance of existing. Then there is a chance of existing. Then there is a chance of existing one break point. Then there is a chance. Then there is a chance of existing. Then there is a chance of existing This is a second chance. Existence. This is existence of, where? Here. Existence of one breakaway point. So these are the possibilities. First I am saying, while doing the problem, while doing the calculations of the procedure, then you can identify here a breakaway point is coming or not. You can identify here breakaway point is coming or not. We will have some procedure, no? We will do that procedure. But before doing the procedure, before doing the general method, before finding the exact value, I can guess here there is a chance, here there is a chance, here there is no chance. Okay. Now this is the possibilities of existing the breakaway point. Now similarly there is a possibilities of existing the break-in point. First we will see what is break-in point. After that we will see the possibilities. First you note down this. Okay. Okay. I hope you understand breakaway point, then you can easily understand the break-in point also. Now see here, this is 1 0, this is another 0. For example, let us take the situation is like this. There exists a root locus branch here. Yes. This is the root locus branch, which means that somewhere the root locus branch, which is nothing but a movement of closed loop pole. Now this is the closed loop pole movement. Now this is the closed loop pole movement. The closed loop poles are searching for what? It is searching for a open loop 0. Am I not? Now, but now the open loop 0 is available here. Therefore, the root locus diagram, the root locus branches now enter into the real axis. Now the root locus branches enter into the real axis at a particular point. Now the root locus branches enter into the real axis at a particular point. The root locus branches enter into the real axis at a particular point is called as break-in point. Is called as break-in point. There exist two adjacently placed zeros. Between them there is a root locus branch. Definitely there is a chance of existing one break-in point. Understand or not? Now there is a situation like this. So we will see all the possibilities, and after that we will now the students, there exist two adjacently placed zeros, but between them there is no break-in point. What is the reason why there is no break-in point? Because this is the root locus branch is odd number. There is no root locus branch. Now this is the root locus branch. Now if there is no root locus branch, there is no movement of the closed loop pole. If there is no closed loop pole movement, then where there is a breakaway, break in, where there is existing, okay, no existence, okay, there is no break in point here, okay. Now this is a one possibility, and there is a second possibility will be similar to the breakaway points. Now the second possibility is now see here, this is the root locus branch. This is not the root locus branch. This entire real axis is a root locus branch. This is the root locus branch. This entire real axis is a root locus branch after this particular 0. Now see here, leftmost side there is a 0. After that 0, entire real axis is a root locus branch. Then there is a chance of existence of where existence of one break-in point. Existence of one break-in point from this particular 0 to minus infinity. Understand or not? These are the possibilities I am saying. These are the possibility conditions I am saying. Then this is correct or not, we will see with the general procedure, such that this shortcut procedure is also useful. Actually, first I am saying general and after the shortcut, but here I am doing reverse. Now this is the possibilities I am giving. Keep these particular possibilities in our mind, and we will go to the general solution. Will be matching or not, we will verify. Okay, now first you take this one. What is the definition of break-in point? Break-in point is a point where the root locus branches enters into the real axis. What about the breakaway point? Breakaway point is a point where the root locus branches leaves the real axis. It is leaving. Now it is entering. Entering is break-in, leaving is breakaway. Okay, note down. Okay, so finally, break point. We will take a few points here. Break point. Breakaway point or break-in point must lies on root locus branches. Is it right or not? The breakaway point or break-in point must and should lies on root locus branches. Second point. Breakaway point is existing at poles, and similarly break-in point is existing at zeros. Break-in point is existing at zeros and breakaway point is existing at poles. But this breakaway point or break-in point must and should lies on root locus branch. Where there is no root locus branch, there is no chance of breakaway point or break-in point. Understand? Now, one more point also I want to say. Let us take one small example here. Let us check. This is one pole. This is another pole. Now, there is a root locus branch here because there is a odd number, right? There is a root locus branch. Now, my question is, as k is changing, poles are moving. As k is changing, poles are moving. Now, these two root locus branches are meet at a particular point. That particular point is called as breakaway point. You know that. Now my question is, what is meaning of breakaway point? Breakaway point is nothing but a leaving point, right? It will leave the real axis. Now my question is, leaving means now I want to shift it from Hyderabad. Okay, I want to shift it from Hyderabad. I am decided I want to shift it from Hyderabad. So if I want to shift it from Hyderabad means now I want to go to Hyderabad to Vijayawada, or Hyderabad to Bangalore, Hyderabad to Delhi, or Hyderabad to Mumbai, Hyderabad to now Bhubaneswar. There is n number of directions, right? Now my question is, when it is leaves the real axis, now if you go in which particular direction, then you will meet 1 0. So if I go in this particular direction, if I go in this particular direction, if I go in this particular direction, how many directions? Infinity directions. Now my question is there anybody is here to say that you go in this particular direction, then you will meet 0. That direction is given by angle of asymptotes. That direction is given by angle of asymptotes theta A. Okay, the angle of asymptote is the direction where in that particular direction if you go, you will meet 0. That we will see. Now first you just take this.